An air source heat pump is really quite a simple piece of kit. It takes a low-grade energy, compresses it, and turns it into a high-grade energy, so we can use that energy now to heat your homes. The way that works, we've got an infinite amount of air. We're taking that air with a fan in the heat pump that sucks the air across a heat exchanger. That heat is converted into boiling refrigerant, which can work down to -20, -40 in some cases. When that refrigerant is now a gas, we can compress it. And once it's compressed, we can send it through another heat exchanger where it gives all that heat that's now compressed and very hot into your heating and hot water of your home. And it goes round in a closed cycle. As you can see, we're currently installing an air source heat pump. This air source heat pump is a split unit, and we needed to use that to give us the versatility of the distance of the pipe runs. So our outdoor unit is 30 metres away from the inside, and we could actually have this up to 60 metres away. The main difference between the existing heating system, whether it be direct electric or gas or oil, is that has a high carbon loading. So the carbon emissions that are burnt and used to generate that are quite high, whereas a heat pump is so efficient that carbon loading is much, much smaller. Heat pumps are very easy to maintain. You have a yearly inspection on your hot water cylinder, same as your existing boiler systems or electric storage heaters. So the maintenance is very, very simple. With an air source heat pump, it's preventative maintenance is much better than reactive maintenance, so making sure the outside unit's nice and clean, free of debris, line strainers are clean, as well as the G3 safety check on your hot water cylinders. With ground source heat pumps, it's exactly the same, it's just one more filter to check, and then you've got water source heat pumps to make sure there's no debris under that water on the collector in the lakes. Some people may be concerned about how you control a heat pump compared to what they have originally in their houses. We can use, in some cases, exactly the same controls. We do like to upgrade them, so you have more modern controls, more effective and more efficient. At Infinity, as we're approved partners for a lot of the manufacturers, we can offer extended warranties up to 7 years. As we've done the heat loss of the property, obviously we need to have the radiators sized to heat that property correctly. So the radiators we need to install may have to be bigger than the existing. So this is a good example of a larger output radiator for quite a large area with limited space. And what you can see here is a domestic hot water cylinder. All heat pumps need a hot water cylinder because it works like a Y-plan system. So what that means is there's a 3-port valve here which diverts the flow of water to either the heating or the hot water coil. Now a heat pump cylinder is different to a standard hot water cylinder because of the coil surface area, somewhere around about 3 meters squared. And we need that to take the heat away from the compressor, away from those fridge lines into your hot water tank. So that's your hot water taken care of. As I mentioned, there's a 3-port valve which diverts between heating and hot water. So we can't have both on at the same time, but what it does is it looks at what's calling for the demand and it'll have a preference for either. So normally the hot water will set the preference, it'll meet the demands of the hot water and then go on to the heating and switch over as and when it's needed. This item here is our specific heat pump filter. It's magnetic and meshed and it works with the Vortex too. So this stops any contaminants from the radiators or existing heating system getting back to our heat pump. A clean system is a healthy system. You can see that we have a filling loop. We've taken the filling loop off as required by building regulations. The fact that we have a standard filling loop that we can top up with normal mains water is good. The reason why is we have a split system, a split heat pump here, so we don't need glycol in our heating circuit. If you had a monoblock system, it's highly advised you use either antifreeze valves or some kind of antifreeze solution in your heating circuit. What you can see here is a temperature sensor for the hot water. So this will create the demand and lose the demand as and when your hot water is being used. There isn't one size fits all with heat pumps, and there's not one size fits all for heating circuits either. This house has a microbore heating system we design bespoke to each property to meet the needs of our customers. We're now in the attic of the property. So when we had a look outside in the garden, we saw the external part of the heat pump, which is the evaporator and the compressor. We had the refrigeration lines. They were run under the garden and up into the attic. So what we have in front of us is the condenser box. The condenser takes the energy from the refrigeration, puts it through a heat exchanger, where it condenses back into water to go back through the circuit again, and then that energy gets transferred into your hot water and heating system. So the components inside this condenser box is your flat plate heat exchanger, your circulation pump, the primary pump, and also there's a backup immersion heater, which helps for the very, very coldest days of the year outside of design temperature.
It's been just over a month now since we've had the installation done, and it's been great to see already the benefits of using the heat pump versus gas to heat our water. It's taking literally like 15 minutes to heat the water up for the whole household. It's blended into the property, it's blended into the garden, and it looks fantastic.